We hear the term data analyst thrown around all the time, but what do they actually do? What's in their toolkit? Well, today, we're going to pry that toolkit right open. We're not talking about buzzwords here, we're talking about the real tools they use every single day to take a messy, confusing problem and turn it into a clear, actionable solution. So, yeah, let's dive in. So, let me ask you this. How do you solve a problem that you can't even see? Because really, that's where every great analysis begins. The biggest, thorniest problems in, business, healthcare, tech, they're usually invisible. They're buried deep inside spreadsheets. They're lost in these giant databases. So, what's an analyst's job? It's pretty simple, really. It's to make the invisible visible. It's about shining a huge spotlight on the problem so we can finally see it and, actually fix it. All right, to make this whole thing less abstract, let's actually follow a real project from start to finish. Picture this, a local hospital. They've got this gut feeling, this problem. They know patients are waiting way too long. But the big question is, why? They have no idea. So that's our challenge. Let's put on our data analyst hats together and see if we can solve this thing. Okay, so here's the thing. Every single data project, I don't care if it's for a hospital or a giant tech company, they all follow a surprisingly similar path. It's a real journey, a structured one that takes you from that vague question to a super concrete action plan. So let's walk through it. And this is basically the roadmap for that journey. It's the 6-step analytics lifecycle. We're going to start right at the top. Step 1, discovery. This is exactly where our hospital is right now. We're defining the problem. Hey, wait times are too long. And we're asking some really important questions, like what does a win even look like here? Getting this first step right is absolutely crucial because, honestly, it sets the stage for everything else to come. All right, so we know the problem. Now we need clues. And in the world of analytics, our clues, well, that's the data. But here's the catch. Data in the real world is never clean. It's not just sitting there ready to go. So this next phase is all about gathering those raw materials and, getting our hands dirty, getting it ready. And right away, we hit our first major hurdle. The hospital's data, oh man, it's a mess. It is all over the place. You've got appointment logs in one system, doctor schedules in a totally different one, and then patient records are somewhere else entirely. It's full of inconsistencies, there are errors, and yeah, it's our job to somehow wrangle all of this chaos into one single usable data set. So where do you even begin with a mess like that? Well, you start with probably the most common, most accessible tool on the entire planet, a spreadsheet. Seriously. Things like Excel and Google Sheets are like the Swiss Army knife for an analyst. They're just perfect for that first pass of cleaning, for sorting through smaller chunks of data, and just kind of getting a feel for what you're working with. They're fast, they're flexible, and hey, pretty much everyone knows their way around one. But okay, what happens when you're not dealing with a few hundred rows, but hundreds of thousands of patient records? Suddenly, your little kitchen knife just isn't going to cut it, right? You need something with a lot more muscle. And this quote, it just perfectly captures that next step up. In that power tool, that's SQL. It stands for Structured Query Language, but what it really is, it's the language analysts use to talk to massive databases. So instead of trying to manually sort a giant file that would crash your computer, you can just write a simple command. You can literally say, hey database, select all the patient appointments from the last 3 years where the wait time was more than 20 minutes. It's how you handle data on a truly massive scale. Okay, so our data is now clean, it's organized, all that prep work is finally done. Phew. Now comes the fun part. This is where we get to go hunting for those hidden patterns, those little connections, those aha moments that are going to finally tell us why patients are waiting so dang long. So with our nice, clean data set all ready to go, we can finally move past just simple sorting and filtering. It is time to bring in the heavy hitters, the real power tools of the analytics world, to dig in and find that root cause. And by heavy hitters, I mean programming languages like Python and R. These are the big guns. With a special library called Pandas, for example, we can do some really complex analysis, like looking at the relationship between doctor schedules and wait times. Or with another one, Scikit-learn, we could even build a model to predict what next Monday's wait times are going to look like. These are the tools that let us find those really subtle patterns that a spreadsheet would never, ever be able to see. So we run our analysis, we let the programs do their thing, and what do you know? Two key culprits, two main reasons for the long waits, they start to emerge from the data. The patterns are becoming crystal clear, and we finally have some concrete answers for the hospital. And boom, There it is. The data is practically shouting at us. Just look at this chart. It's not even a close call. Wait times on Mondays are just through the roof compared to Wednesday or Friday. This isn't just a hunch the nurses had anymore. Nope, this is a cold, hard fact. And it's our first huge breakthrough. And then, here's the second piece of the puzzle. We started looking at different types of patients. And it turns out, new patients wait, on average, a full 12 minutes longer than patients who've been there before. That is such a specific, actionable insight. The problem isn't just everybody waits too long. No, it's hitting one particular group of people way harder than others. Okay, so finding these things it's awesome, right? But believe it or not, that's only half the battle. Because an amazing insight that just sits in a spreadsheet or a Python script, it's completely useless. The final and maybe most critical part of this whole process is communication. It's all about turning what we found into a story that real people can understand and, more importantly, act on. I mean, think about it for a second. We can't just walk up to the clinic managers and hand them a complicated Python script, right? They're busy running a hospital. They need to see the main point, like instantly. So our job now is to become a translator. We have to translate our geeky findings for the people on the ground who can actually make a change. And this is exactly where visualization tools like Tableau or Power BI come in. They are absolute game changers. These things are designed for one purpose: telling stories with data. So we can take our findings, the whole Monday thing and the new patient problem, and build a simple interactive dashboard. Now, that clinic manager can see the entire problem in a single glance. It just shows you the incredible power of making data visual. So there you have it. We followed our hospital case study all the way from a fuzzy problem to a really clear insight. We saw how an analyst kind of levels up, right? From spreadsheets to SQL to Python. But now let's zoom out a bit, because in the real world, not every analyst uses all of these tools all the time. Let's take a look at how this toolkit maps to different jobs in the data world. And this is super helpful for understanding how the industry is structured. You've got your BI analyst. That's business intelligence. They're the ones living in Tableau and Power BI, building those awesome dashboards we just talked about. Then you have the data scientist who spends most of their time in Python or R, building those complex predictive models. And before all that, you have the data engineer, using heavy-duty tools like Spark to build the actual data pipelines that feed everybody else. See, each role has its own favorite part of the toolkit. So let's just do a quick recap of the whole spectrum. You've got spreadsheets like Excel as the universal starting point. Then there's SQL, the language of databases. You've got Python and R for when you need to do a really deep analysis. Tableau is there for telling the story. For absolutely massive data sets, you have tools like Spark. And there's even specialized stuff like Google Analytics for tracking digital behavior. It's a really powerful, really diverse tool. But when you really get down to it, this whole thing is about more than just the tools. Learning this stuff, it's not just about becoming a technical wizard. It's about learning a completely new way to see the world, a new way to approach problems. It's really about getting inside that analytical mindset, the one that can take a pile of raw data and turn it into something with real-world value. So I'll leave you with this question. Now that you've had a peek inside the Analyst Toolkit, what are the invisible problems that are all around you, in your job, maybe even in your own life? What's that problem that's just sitting there, waiting for the right data and the right tool to finally bring it into the light?